Picture this. You're standing on a perfectly straight stretch of ancient stone, looking down a road that could slice through mountains, cross rivers, and connect entire continents. The Romans didn't just build roads, they built highways that would make modern engineers weep with envy. We're talking about construction so precise that after 2,000 years, you can still drive on some of these routes today. That's not just impressive, that's borderline supernatural. But here's what most people don't realize about Roman roads. They weren't just throwing stones on the ground and calling it a day. These guys developed a multi-layer construction system so advanced that we're still using modified versions of their techniques in modern highway construction. Think about that for a second. We're borrowing engineering secrets from people who lived before electricity was even a dream. The numbers alone will blow your mind. At the height of the Roman Empire, their road network stretched over 250,000 miles. That's enough road to circle the Earth 10 times with enough left over to build a highway to the moon. And they built all of this with nothing but hand tools, animal power, and sheer human determination. No bulldozers, no concrete mixers, no GPS systems. Just raw engineering genius that would make today's construction crews look like they're playing with toy blocks. Now here's where it gets really interesting. Every single mile of Roman road followed the same basic construction principles, whether they were building through the scorching deserts of North Africa or the frozen forests of Britain. They had a system so standardized that you could drop a Roman road crew anywhere in the empire, and they'd build you a highway that would last for centuries. That level of consistency across such a massive area, that's organizational brilliance that most modern companies would kill for. Before we dive into the incredible engineering behind these ancient highways, make sure to hit that subscribe button and give this video a like. I want to hear from you in the comments about what surprised you most about Roman road construction. Trust me, we're just getting started with the mind-blowing details. The story of how Romans built their legendary roads starts with something most people never think about: the survey. You can't just start laying stones and hope for the best. Every Roman road began with a team of engineers who had to solve a puzzle that would challenge even modern surveyors. How do you create a perfectly straight line across hundreds of miles of varied terrain using nothing but primitive tools? Meet the groma, Rome's secret weapon for straight-line surveying. This wasn't some fancy piece of equipment. It was basically two wooden sticks crossed at right angles with plumb bobs hanging from each arm. Sounds simple, right? Wrong. In the hands of a skilled Roman surveyor, this humble tool could establish sightlines so precise that roads built with the groma are still straighter than most modern highways. The technique required two surveyors working in perfect coordination, with one sighting along the plumb bob lines, while the other positioned markers at precise intervals. But straight lines were only half the battle. Roman engineers knew something that would take other civilizations centuries to figure out. Water is the enemy of every road ever built. That's where the chorobates came in, a leveling instrument that looked like a wooden table with legs, complete with water channels and plumb bobs for checking level ground. This thing was so accurate that Roman roads had drainage gradients calculated to within fractions of an inch per mile. Here's what made Roman surveyors truly remarkable. They didn't just avoid obstacles, they conquered them. Hills got cut through, valleys got filled, rivers got bridged, and swamps got causewayed. The famous Appian Way, one of Rome's first major highways, cut straight through terrain that modern engineers would route around. These guys looked at a mountain and thought, that's not a problem, that's just more work. The survey process itself was a masterpiece of military precision. A typical surveying team consisted of a chief engineer, 2 instrument operators, a team of rodmen for marking distances, and enough labourers to clear sight lines through forests. They'd work in stages, establishing primary control points on high ground, then filling in the details with secondary surveys. The whole process moved like a well-oiled machine, with each team member knowing exactly when to move, where to stand, and what measurements to record. Once the survey line was established, the real work began. Roman road construction wasn't just about moving dirt and laying stones. It was about creating a drainage system that would keep the road surface dry for centuries. Every Roman road started with side ditches, not just shallow grooves, but carefully engineered channels designed to capture and redirect water away from the roadbed. The clearing process alone was a massive undertaking. Roman work crews would strip vegetation from a corridor typically 40 to 60 feet wide, removing not just trees and bushes, but also the root systems that could later undermine the road structure. They understood something that many modern road builders still struggle with. Organic material and permanent roads don't mix. Every bit of vegetation had to go, down to the smallest root fibre. The ditching work required both engineering precision and backbreaking labour. These weren't random holes in the ground. They were carefully graded channels with specific slopes calculated to move water efficiently without causing erosion. The excavated material didn't go to waste either. Every shovelful of dirt from the ditches went into building up the crowned roadbed, the raised centre section that would form the foundation for all the layers to come. But here's where Roman engineering really showed its genius: the crown. Modern drivers take it for granted that roads are slightly higher in the middle than at the edges. But the Romans perfected this concept 2,000 years ago. The crown wasn't just about drainage. It was about distributing the weight of traffic evenly across the road surface, while ensuring that water would always flow toward the ditches rather than pooling on the roadway. Creating the proper crown required mathematical precision that would impress modern civil engineers. Roman road builders calculated the exact curve needed to shed water while maintaining a surface that carts and marching soldiers could navigate comfortably. Too steep, and vehicles would slide toward the edges. Too flat, and water would stand on the road surface. They got it right through a combination of mathematical knowledge and practical experience that took generations to perfect. The foundation layer, called the statumen, was where Roman roads really began to separate themselves from every other ancient highway system. This wasn't just a matter of dumping rocks and calling it good. The statumen was a carefully constructed layer of large stones, typically 12 to 18 inches thick, laid in a specific pattern designed to distribute weight and provide drainage. Each stone was hand-selected for size and shape, then positioned to interlock with its neighbours, like pieces of a massive three-dimensional puzzle. The quality control for the statumen would make modern construction supervisors jealous. Roman engineers insisted on stones of specific sizes, large enough to provide structural support, but small enough to create a relatively level surface for the next layer. No stone was placed randomly. Each one was positioned to contribute to the overall stability of the road structure. The gaps between stones weren't empty spaces. They were drainage channels that would carry water away from the road surface for centuries. On top of the statumen came the rudus, a layer of smaller stones and gravel bound together and compacted to create a solid, level surface. This is where Roman road construction really showed its sophistication. The rudus wasn't just loose gravel. It was an engineered mixture of different size materials, each chosen to fill specific gaps and create maximum compaction. The binding agent was often a mixture of lime mortar and clay, creating a concrete-like surface that could support enormous loads while remaining flexible enough to accommodate ground movement. The compaction process for the rudus was pure Roman efficiency. Work crews would spread the material in thin lifts, then compact each layer using heavy wooden rammers operated by teams of workers. The process continued until the entire rudus layer achieved the density and levelness required by Roman engineering standards. This wasn't guesswork. Roman engineers had specific tests to determine when the rudus was properly compacted and ready for the next layer. The third layer, known as the nucleus, was where Roman engineering reached almost artistic levels of precision. This wasn't just another layer of rocks. It was a carefully crafted bedding of fine sand and small gravel that would cradle the final stone surface like a custom-fitted mattress. The particle size had to be just right, too large, and the paving stones would sit unevenly, too small, and the layer wouldn't provide adequate support under heavy loads. What made the nucleus truly remarkable was how Roman engineers understood drainage at a microscopic level. The mixture of sand and fine gravel created thousands of tiny channels that would wick moisture away from the paving stones above while preventing water from pooling anywhere in the road structure. Modern highway engineers are still trying to perfect this kind of subsurface drainage, yet the Romans figured it out using nothing but observation and trial and error. The preparation of the nucleus required patience that would drive most modern construction crews to distraction. Workers would spread the material in thin layers, carefully raking it to achieve perfect levelness before compacting it with specialized tools. Some crews used wooden floats to smooth the surface, while others employed rollers made from stone cylinders. The entire process had to be completed in dry weather. One unexpected rainstorm could ruin weeks of careful work. Then came the crown jewel of Roman road construction, the paving stones themselves. These weren't just random rocks picked up from nearby fields. Roman paving stones were carefully cut blocks of hard stone, each one shaped to fit precisely with its neighbors. The most prized stones came from volcanic regions, basalt and similar materials that could withstand centuries of traffic without showing significant wear. The cutting and shaping of paving stones was a specialized craft that took years to master. Stone cutters would select blocks based on their grain structure, color, and hardness, then shape them using techniques that created incredibly tight joints. The goal wasn't just durability, it was creating a surface so smooth that cartwheels would roll over it without jarring the cargo or passengers. Some Roman roads achieved surface smoothness that rivals modern asphalt highways. But here's what really separated Roman paving from everything that came before or after: the camber. Each individual stone was cut with a slight curve that contributed to the overall crown of the road. When hundreds of these precisely shaped stones were fitted together, they created a surface that shed water like a roof while providing a comfortable ride for wheeled traffic. The mathematical precision required to calculate these curves and then execute them in stone is mind-boggling. The installation process for paving stones was like watching a massive jigsaw puzzle come together. Master masons would select each stone individually, test fit it against its neighbors, then make final adjustments with chisels and hammers. No gaps were acceptable. Roman roads were famous for joints so tight you couldn't slip a knife blade between the stones. This level of precision served a dual purpose. It prevented water infiltration and distributed traffic loads evenly across the entire road surface. Curbstones provided the finishing touch that locked everything together. These weren't just decorative borders, they were structural elements that prevented the road surface from spreading under load. Roman curbs were massive blocks of stone, often weighing several hundred pounds each, set deep into the roadbed and extending well above the paving surface. They formed an impenetrable barrier that would contain the road structure for centuries. The engineering behind curbstone placement reveals just how thoroughly Romans understood structural mechanics. Each curb block was positioned to resist both vertical loads from traffic and horizontal forces from frost heave and ground movement. The stones were often connected to each other with iron clamps and set in beds of mortar that would cure to rock-like hardness. Some Roman curbs have remained perfectly aligned for over 1,500 years. Water management didn't stop at surface drainage. Roman engineers understood that even the best crowned road would encounter situations where water had nowhere to go. That's where culverts came in. Small, stone-lined channels that carried water under the road surface at low points and stream crossings. These weren't afterthoughts added during construction. They were integral parts of the design that were planned during the initial survey. Roman culverts were masterpieces of hydraulic engineering in miniature. The channels were lined with carefully fitted stones and covered with massive capstone slabs that could support the full weight of the road surface above. The sizing of these culverts was calculated to handle not just normal water flow, but also the flash floods that could occur during heavy rains. Many Roman culverts are still functioning today, carrying water under roads that have been in continuous use for 2 millennia. The construction of culverts required specialized skills that combined stone masonry with hydraulic engineering. Workers had to maintain precise grades to ensure proper water flow, while building structures strong enough to support tons of stone and traffic loads above. The joints between stones were sealed with hydraulic mortar that would harden underwater, a technology that wouldn't be rediscovered in Europe for over 1,000 years after the fall of Rome. Mile markers represented another level of Roman organizational genius. These weren't just distance indicators. They were information systems that provided travelers with precise data about their location, destination, and the authority responsible for road maintenance. Each milestone was a carefully carved stone column that took skilled craftsmen days to complete. Yet Romans placed them along every major road throughout their empire. The information carved into milestones reveals the bureaucratic sophistication of Roman road administration. Most included the distance to major cities, the name of the emperor or official who built or maintained that section of road, and often additional details about local geography or services. Some milestones even included warnings about road conditions ahead, or advertisements for services available in nearby towns. Mile markers weren't placed randomly. They followed a standardized system that allowed travelers to calculate journey times and plan rest stops with mathematical precision. The Roman mile was slightly shorter than our modern mile, about 4,800 feet, but it was consistent throughout the empire. This standardization meant that a merchant in Britain could read a milestone and know exactly how long it would take to reach his destination, using the same calculations that worked in Spain or Syria. The placement of milestones was itself an engineering challenge that most people never consider. Each marker stone weighed between 500 and 1,000 pounds and had to be transported to its exact location, then set in a foundation deep enough to prevent frost heave or vandalism. Roman work crews developed specialized techniques for moving these massive stones using wooden rollers, ramps, and lever systems that could position a milestone within inches of its surveyed location. But here's where Roman road building gets really fascinating: the finishing work. After months of surveying, excavating, and laying stone, specialized teams would arrive to complete the surface preparation. These weren't just laborers with shovels. They were skilled craftsmen who understood that the difference between a good road and a great road lay in the final details that most people would never notice. The joint sanding process alone was an art form. Workers would carefully sweep fine sand into every gap between paving stones, ensuring that water couldn't penetrate the surface while creating a smooth transition between individual blocks. This wasn't random sand from the nearest beach. It was specifically graded material that would compact properly and resist erosion. The sand mixture often included lime dust that would harden when wet, essentially creating a waterproof seal between stones. Edge dressing required the skills of a master stone mason. Any paving stone that sat even slightly higher than its neighbors would create a jarring bump that could damage cartwheels and spook horses. Roman finishing crews would identify these high spots using long wooden straight edges, then carefully chisel away the excess material until the entire road surface was perfectly level. The precision required for this work was extraordinary. Variations of more than a quarter inch over a 20-foot span were considered unacceptable. The final step in Roman road construction sounds almost ridiculous by modern standards. They would roll loaded carts over the entire surface to seat the stones properly. This wasn't just a few passes with empty wagons. It was a systematic process using progressively heavier loads that would reveal any weak spots or unstable areas in the road surface. If a section showed signs of settling or shifting under these test loads, The entire area would be torn up and rebuilt to Roman standards. What made this rolling process truly remarkable was its thoroughness. Roman engineers understood that a road surface was only as strong as its weakest point. Every square foot of paving had to withstand the heaviest loads that would ever travel the road, and the only way to verify this strength was through destructive testing using actual traffic conditions. Some sections would be rolled for days until the engineers were satisfied that nothing would shift or settle once the road opened for public use. The quality control standards for Roman roads would make modern highway inspectors weep with envy. Every layer was checked and approved before the next phase could begin. The statumen had to pass tests for stone size, placement pattern, and drainage capability. The rudus was checked for compaction, levelness, and proper binding. The nucleus was tested for grade, material composition, and moisture content. And the final paving was subjected to dimensional checks so precise that variations were measured in fractions of inches. But building the road was only the beginning of the Roman highway story. These engineers understood something that many modern road builders are still learning. Maintenance isn't an afterthought. It's an integral part of road design. Every Roman road was built with maintenance access in mind, and every section came with detailed instructions for the specific care it would need to remain functional for generations. The maintenance routines that kept Roman roads operational for centuries were as systematic as the original construction. Drainage ditches required regular cleaning to prevent silt buildup that could cause water to back up onto the road surface. This wasn't just occasional scraping. It was scheduled maintenance that happened multiple times per year, with specific techniques for different types of soil and drainage conditions. Culvert maintenance was even more critical than ditch cleaning. A single blocked culvert could undermine an entire section of road by allowing water to pool and freeze, creating forces that could crack even the strongest stone construction. Roman maintenance crews developed specialized tools for cleaning culverts, including curved scrapers that could remove debris from stone channels without damaging the carefully fitted masonry. The replacement of damaged paving stones required skills that bordered on archaeological precision. A single cracked or broken stone couldn't just be chipped out and replaced. The surrounding stones had to be carefully removed, the underlying nucleus checked and repaired if necessary, and the entire section rebuilt to match the original construction standards. This level of maintenance meant that some sections of Roman roads were essentially rebuilt multiple times over the centuries, while maintaining their original structural integrity. Crown maintenance was perhaps the most subtle but important aspect of keeping Roman roads functional. Heavy traffic would gradually wear down the high center of the road, reducing the drainage gradient that kept water flowing toward the ditches. Roman maintenance crews would periodically add new material to restore the proper crown, but this wasn't just dumping gravel on top of the existing surface. The new material had to be carefully graded and compacted to match the original road geometry. The mathematics behind Roman road maintenance reveals an understanding of structural engineering that wouldn't be seen again in Europe for over 1,000 years. Maintenance schedules were calculated based on traffic volume, weather patterns, and the specific materials used in each section of road. Different stone types were at different rates, different soil conditions created different maintenance challenges, and different climate zones required different approaches to preserving road integrity. Record keeping for Roman road maintenance was as sophisticated as the engineering itself. Detailed logs tracked which sections needed attention, what work had been performed, and when the next maintenance cycle was due. These records allowed Roman administrators to predict maintenance costs, schedule work crews efficiently, and ensure that no section of road was neglected until problems became serious enough to require complete reconstruction. The tools used for Roman road maintenance were marvels of practical engineering in their own right. Specialized scrapers for ditch cleaning, lifting devices for moving heavy paving stones, compaction tools for crown repair, and measuring instruments for checking drainage grades, all designed specifically for the unique challenges of maintaining stone-paved highways. Some of these tools were so effective that similar designs continued to be used for road maintenance well into the modern era. Seasonal maintenance schedules reveal how thoroughly Romans understood the relationship between weather and road deterioration. Spring maintenance focused on repairing frost damage and clearing debris from winter storms. Summer work concentrated on major repairs that required dry weather for proper execution. Fall maintenance prepared roads for winter by ensuring proper drainage and replacing any stones that might fail under freeze-thaw cycles. The economic impact of Roman maintenance systems was staggering. By investing in systematic upkeep, Romans were able to keep their roads functional for centuries rather than decades. This wasn't just about transportation, it was about maintaining the economic lifelines that held the empire together. A well-maintained road could handle 10 times the traffic volume of a neglected one, while lasting 50 times longer. Mathematics that made Roman road maintenance one of the best investments in human history. But perhaps the most impressive aspect of Roman road maintenance was its integration with the broader imperial administrative system. Road maintenance wasn't handled by local communities or private contractors. It was a coordinated effort managed by professional engineers who understood that the road network was a strategic asset, requiring military-level organization and funding. The legacy of Roman maintenance practices extends far beyond ancient history. Modern highway departments still use modified versions of Roman maintenance techniques, and the basic principles of systematic upkeep that Romans developed remain the foundation of infrastructure management worldwide. When you drive on a modern highway that's been properly maintained, you're benefiting from engineering wisdom that's over 2,000 years old. The numbers behind Roman road construction tell a story that would make modern project managers question everything they thought they knew about large-scale infrastructure. A typical Roman road crew could advance between 1 and 3 miles per day on level ground. That's not just laying stones, but completing the entire 4-layer system to full specifications. Think about that for a second. These guys were building highways that would last 2,000 years at a pace that most modern construction crews would struggle to match with all their mechanical advantages. The crew organization was military precision applied to civilian engineering. A standard Roman road building unit consisted of around 200 men divided into specialized teams, each with specific responsibilities that never overlapped. You had the survey team constantly working ahead of the main force, the excavation crews who cleared and ditched, the stone layers who built up the structural foundations, and the paving specialists who created those perfect stone surfaces. No one stood around waiting for someone else to finish their job. Every team knew exactly when to move and where to position themselves. But here's where Roman engineering really shows its genius. They figured out how to standardize construction across an empire that spanned 3 continents and dozens of different climate zones. A Roman road built in the scorching heat of Egypt used the same basic techniques as one constructed in the freezing forests of Germany. The materials might be different: local stone, local gravel, local sand, but the principles remained absolutely consistent. The stone selection process alone was a masterclass in materials engineering that modern construction companies would envy. Romans didn't just grab whatever rocks were lying around. They developed detailed specifications for each layer based on centuries of trial and error. The statumen required stones between 6 and 12 inches in diameter, with specific shape requirements that ensured proper interlocking. Too round, and they wouldn't stay in place. Too angular, and they wouldn't distribute loads properly. The rudus layer demanded even more precision in material selection. The mixture of crushed stone and binding agents had to meet exact proportions. Too much binding material and the layer would be too rigid, cracking under load. Too little, and it wouldn't hold together under traffic. Roman engineers developed field tests that could determine the proper mixture ratios, using nothing but visual inspection and simple hand tools. Quality control during construction was ruthless by any standard. Roman engineers would reject entire sections of work if they didn't meet specifications, no matter how much time and effort had been invested. There are records of crews being forced to tear up completed road sections because the stone joints weren't tight enough, or the drainage gradient was off by fractions of an inch. This wasn't perfectionism run amok. It was the recognition that substandard work would create maintenance nightmares for generations. The logistics of supplying a Roman road construction project boggle the mind. A single mile of highway required approximately 15,000 tons of stone. That's the weight of about 100 modern houses worth of material that had to be quarried, transported, and positioned by hand. The organization required to keep materials flowing to construction sites across hundreds of miles of wilderness makes modern supply chain management look simple by comparison. Transportation of materials was an engineering challenge in itself. Romans developed specialized carts and sledges designed specifically for moving massive stone blocks over rough terrain. Some of the largest paving stones weighed over a ton each, requiring teams of oxen and elaborate pulley systems just to load them onto transport vehicles. The roads used to build roads, temporary supply routes that would be abandoned once construction was complete, were often engineering marvels in their own right. The seasonal rhythm of Roman road construction reveals a sophisticated understanding of how weather affects different aspects of building. Spring was for surveying and clearing, taking advantage of good visibility and manageable ground conditions. Summer focused on the heavy stonework that required dry weather for proper mortar curing. Fall was for finishing work and final inspections before winter weather made further progress impossible. Winter wasn't downtime for Roman road crews, it was preparation season. Crews would spend the cold months quarrying stone for the next year's construction, maintaining tools and equipment, and planning routes for upcoming projects. Some crews even used winter months to prefabricate complex stone elements like bridge components and culvert sections that could be quickly installed once construction season resumed. The economics of Roman road building were staggering even by modern standards. A single mile of major highway cost the equivalent of about 50 years of wages for a skilled craftsman, roughly $5 million in today's money. But Romans understood that this wasn't an expense. It was an investment that would pay dividends for centuries. A well-built road would generate economic benefits worth hundreds of times its construction cost over its operational lifetime. The return on investment from Roman roads was measurable in multiple ways. Trade increased dramatically along new routes as merchants could move goods faster and more reliably. Tax collection became more efficient as administrators could travel quickly between administrative centers. Military response times improved as legions could march rapidly to trouble spots. The economic multiplier effect of road construction was so well understood that Roman emperors competed to fund major highway projects as legacy achievements. But perhaps the most impressive aspect of Roman road construction wasn't the engineering or the economics. It was the sheer audacity of the vision. These engineers looked at a continent covered with forests, mountains, rivers, and swamps, and said, "We're going to connect every major city with highways that will last forever." Then they actually did it. The psychological impact of this achievement on both Romans and their neighbors was immense. The standardization of Roman road construction created something unprecedented in human history. A transportation network where a traveler could journey from Scotland to Syria and encounter the same quality of highway throughout the entire trip. Mile markers would be consistent, road surfaces would meet the same standards, and maintenance quality would be uniform. This level of standardization wouldn't be seen again until the modern interstate highway system. The training required to produce skilled Roman road builders was as systematic as the construction process itself. Master engineers would take apprentices through years of instruction covering surveying, stone cutting, hydraulic engineering, and project management. The knowledge wasn't just practical. It included the mathematical principles behind proper road geometry and the physics of load distribution through layered construction. Documentation of Roman road building techniques was preserved in engineering manuals that served as textbooks for centuries. These weren't just collections of rules, they were comprehensive guides that explained not just how to build roads, but why specific techniques worked. The theoretical understanding behind Roman engineering was sophisticated enough that their principles form the foundation of modern highway design. So there you have it, the incredible story of Roman road construction, from the first survey line to the final cart rolling over perfectly fitted stones. These ancient engineers didn't just build roads, they created a transportation revolution that connected continents and lasted millennia. Their four-layer system, precision drainage, and obsessive maintenance standards prove that sometimes the old ways really were the best ways. The next time you're cruising down a modern highway, remember that you're traveling on the shoulders of Roman giants who figured out the secrets of permanent pavement 2,000 years ago.